Way familiar. Could you come up with formulas from the names? So Miles, Jim, Sarah, Fonja. Hannah. Rachel. Julie, your internet is super now. Your picture is perfect. Penny. Gerald. So Gerald, had we done enough of this for you to be able to do this? I think we have. You can give me a thumbs up. Yes or no?
I hope so.
I hope so
I don't
too.
know.
So you're looking at your periodic table and where they come, what groups they're in to work out their charge. And remember, it's the once you have their charge. So if the first one is potassium and this is iodine, and you do your drop downs. So we have Eva, done Penny, we have Molly. We have Sarah and we have Juliet. 2, 4, 6, 8, 10, 12, 14, 16. So we're missing Mikey, Charlie, Mark.
I'm near miss.
Are you here? Thank you, Mikey. Add you to the list. So, Charlie and Mark. Mark, you have no hair. It's lovely though.
Thank you.
Okay, happy to start just going through them. So this was just a little reminder. So this is the drop down, and the topic that we're doing is, why are you doing this to me now? Excuse me. So the topic that we're doing now is going to we're going to have to be able to work out the charge of ions. So knowing your complex ions is going to become very important. So this is just a drop down. You figure out what group they're in. So potassium group 1, iodine group 7. You give them their charge, drop down that number of equivalents to give you your formula. So calcium is easy because it's group 2, but sulfate is a complex ion. So it's SO4 2-, and the charges go 1 to 1. So it would be a 2:2, but they become 1 to 1 in their formula. Similarly with magnesium carbonate, carbonate has a 2- charge. So when you drop down, it becomes a 1:1. And sodium hydroxide, OH- is your complex ion. So NaOH. And the last one, aluminium chloride. Aluminium is 3+, chlorine is 1-. So you have 1 aluminium to 3 chlorines. So that was just a teeny tiny reminder on writing formulas from names. you are going to be using something like this, and we're going to be working out what are called oxidation states for, say, sulfur initially. So it's really important that you know the charges and you know the formulas. Are we happy to start? So it's page 104 in my book. It's the next topic on in our list, and it's oxidation reduction, and it's shorthand called Redox. So today we will do a little bit of this part of it, and we'll obviously work on it, but there's a thing called oil rig. So some of my biologists, we've talked about it when we did respiration. This is obvious, this is experiment. We can't do that currently because obviously we're not in lesson, and realistically we probably need to do the negative ions that we didn't do last year this year before it. So that's will all be on the to-do list for when we go back. And I don't teach all of Redox in one go, so we will do a little portion of this when we go to form 6. Sorry, that should be 6. So you're going today to learn how to describe oxidation in 2 ways. And if you can describe oxidation, you can describe reduction. And we have oxidizing and reducing agents, and we'll give you the hint to recognize what goes with what. So this particular reaction, so someone's going to have to turn on their mic and be brave. Tell me please what is happening to magnesium here, or what's happening to copper as it goes from left to right.
Copper is losing an oxygen.
Copper is losing an oxygen, and what's happening to magnesium?
Gaining one.
Thank you so much. Okay, so oxidation started off pretty much as a simple idea on the basis of the equation that you're looking at, because it's blatantly obvious from this that magnesium has gained oxygen, so therefore we can say it has been oxidized. We've added oxygen to it, and the flip is that copper has lost oxygen and it has been reduced. So reduction is when something loses oxygen, and it is the opposite of oxidation. So that's really easy to recognize in an equation like this, because it's blatantly obvious once you know your stuff. Okay, I'm going to flip if that's okay. So oxidation reduction can be shortened to redox, so you might see that when you read certain books, but what redox involves is the transfer of electrons. So not all equations will be a redox equation, and when we move further into this, you'll have ways to work it out and recognize, is this a redox equation or not. And chemists use a thing called oil rig. So oil rig is one version of defining oxidation reduction, and I'm going to give you another kind of silly sentence of mine in which to do it. So for my biologists that have done respiration, can you remember what oil rig was or is?
Oxidation is lost, reduction is gain.
Reduction is gain. So we talked about this when we talked about pyruvate being reduced to lactic acid or ethanol and carbon dioxide. So this is something, and they will ask you a question that says define oxidation in terms of electrons. So this will be your answer. So oxidation is loss, reduction is gain of electrons, and then that's why we call it oil rig. So this is a definition, and you will need to know it. So if you're happy, yes, nobody's screaming. All right, so we're going to look at this reaction in a little bit more detail. And the way we're going to look at it is we're going to turn these guys into their ions. So somebody else that hasn't had a chat this morning, if I'm going to separate copper and oxygen into their ions, what charge am I going to give them from that formula? Be brave. So what's the charge on oxygen always?
-2.
Thanking you. So it's 2 negative. So what does that make copper has to be? You can do this. So if this is 2 negative, the copper has to be... Show me with your fingers. I can see some of you on screen. Thank you, Jim. Okay, so if this is 2 negative, copper has to be 2 positive. So over here we do the exact same thing. Oxygen here is 2 negative. Magnesium has to be 2 positive. So magnesium will always be 2 positive because of where it resides in the periodic table. Copper here has variable valency, and you can only determine its charge by the other thing in its formula. Okay, so we ignore the oxygen because it is the same on both sides. So this is called, the oxygen here is called a spectator ion. It doesn't change either side of your arrow. So now I can write the equation above like this. Cu2 plus goes to Mg2 plus Cu. Now, you can tell from that without ever seeing oxygen which one of them has gained electrons. So if something has gained electrons, so if I'm going from here with the copper 2 plus, it has 2 extra positive charges. It has obviously gained electrons when it's gone to the other side. So oxidation is loss, reduction is gain. So this must be reduced. And here, am I doing that right? I'm doing that right. Yeah, I'm doing that right. Okay. So when you will get an equation, you will have to be able to determine what's oxidized and what's reduced, and this is the quickest way of doing it. So oxidation is loss of electrons, and to lose electrons I would have to be positively charged by the end, and reduction is gain of electrons, so I'll either have extra negatives or my oxidation number will decrease. I'll give you a little hint for this in a second, but the other part that you need to get for this is we write what's called half equations. So this is where we take just the magnesium portion. So magnesium goes to Mg2 plus, and it has lost 2 electrons. So essentially, if you have Mg or Cu, for want of a better way, you can put a little charge of 0 on it. So it's going from 0 to +2. I've obviously lost electrons, and in chemistry we don't subtract the electrons from the magnesium, we put them on this side. And similarly for the copper, copper 2 plus, copper has gained 2 electrons to become Cu as so. Now, do we have any questions on this? We are going to do so many of these that it'll be scary, but so if you wish to put, you can just put ox here and red here. So as I say, we never subtract electrons, we always add them to one side. So this magnesium here has given its 2 electrons, and they're going to end up being given to the copper ion to make copper. Now all is quiet, as they say on the Western Front. So I'm going to give you my other silly sentence, if you're okay. So silence, any questions? Or we all have brains just thudded on the desk? Okay, we'll be an optimist. So this is, I've made these up for myself. So OIR is kind of like air in my head, but oxidation is an increase in oxidation number. And the OR stands for, you always put the electrons on the right hand side when you write your half equation. And reduction, DL, I watch too much, what is it, like Law and Order, So on the down low, so reduction, you get a decrease in your oxidation number, and it's the left hand side for electrons. So both oil rig and these two silly sayings can kind of help you figure out how to write your equations and what it is that they are telling you. So oxidation is loss of electrons. If you lose electrons, you'll get an increase in oxidation number. And if you have to write your half equation, you will put those electrons on the right-hand side. Reduction is gain of electrons. That corresponds to a decrease in oxidation number. And you will put the electrons on the left-hand side for your half equation. So both oil rig and OR and RDL all go together. They will all help you. So thumbs up for the people I can see. I can see 10 of you. Are we happy to move? Yeah. Jim is the only one. Miles is just sitting there going, yeah, no. Thank you, Miles. Okay, so here is the other rule. Once you figure out what is oxidized, this is the reducing agent. So the thing that's oxidized is the reducing agent, and then in the flip world, whatever is reduced is your oxidizing agent. So they work opposite to each other. Okay, so we're just going to rewrite our two half equations again. Like so. So they're going to fill into your little gap up here, and what it's showing you is the two electrons that were released from magnesium here end up going to the copper. So there should be plus 2e and a little arrow to make your copper. So the rule is the magnesium is the reducing agent because it supplies electrons to the other substance, which is going to be reduced. So oxidation is loss, reduction is gain. The reducing agent supplies the electrons for the thing that's to be reduced. Now, it is unlikely that the SEC will ask you to put it into these words. Usually what they do is they give you a full equation. They ask you to do our little joiny arrows, one for ox and one for red, and you then can just circle what you think is the oxidizing agent or the reducing agent. So this part is just an FYI to explain it for you. So they will always be something that gives away electrons.
What does it say after the gained electrons? Then it says copper 2 plus, and then it says plus 2 something.
So it should read like plus 2e minus, it's just the arrow is on top of it, Cu. That better, Miles?
Thanks.
Okay, and then on the flip side, if you're happy. So, yeah, you look like you're still writing. So the flip side is that the copper is referred to as your oxidizing agent, and I spelled that wrong, apologies. It's referred to as your oxidizing agent. Because it's taking the electrons from the other substance and is itself reduced. So the thing that is oxidized is the reducing agent, and the thing that is reduced is the oxidizing agent. Okay, we think we look like we're not writing. So you have the next two little slides on the page 105. So this is just showing you in oxidation, a compound loses electrons, it is the reducing agent, and here the oxidizing agent gains electrons, it is reduced. And then this is just literally the next one, a summary of everything we've done today. So you've got your two definitions for oxidation and reduction. We have oil rig and we have the OIR and RDL. So this is everything that you need to make sure that you understand today. So it's either the gain of oxygen or the loss of oxygen in simple terms, but this is what the SEC is going to be asking you. Define oxidation in terms of electrons. So you tell them it's loss, and they'll ask you to define oxidation in terms of change in oxidation number. So you need to know oxidation is an increase in number, reduction is a decrease in oxidation number, and which is an oxidizing agent and which is a reducing agent. So just the last little bits, these are just some examples of redox reagents. So when we do our titrations, we do a titration with bleach and we do a titration with manganate. They will be our oxidizing agents, and we also do with sodium thiosulfate down here. So these guys are all oxidizing agents because they gain electrons, and these guys are all reducing agents because they lose their electrons. Our practical that we do is based on the halogens. So we'll have another example of when we get it there. Now that is everything from the theory side of today. It's kind of short and sweet because you don't want to melt your brain too much. What are we doing? Redox. So I have set you some questions in the class notebook link. It should have pinged, or if it's not, it's going to ping very soon. The questions are from Chemistry Live, and they are 14.1 and 14.2. I'm just going to look and show you 14.2, give you an example of it, and then you can either start your homework for the last bit or you can go away and go from there. So this is the first example in 4.2, and the question is asking you indicate clearly by showing electron loss or gain which species is oxidized and which is reduced, and show the oxidizing and reducing agents in each of the reactions. So the first thing that you need to do up here is you need to look at this part and you need to turn it into their ions. So you have Ca2 plus and you have O2 minus. So now we're using the OIR and the RDL. So oxidation is an increase in oxidation number. So the oxidation number, you can take these guys as having an oxidation number of 0. They have no charge, and I'll explain, I think it is tomorrow, why that is, or the next time we see each other. Okay, so the way then that you highlight for your examiner what they've asked you in the question, so I just need to change my color pen so you can see it, is you would go up here to here and all you say is oxidized, because there is an increase in oxidation number. It's essentially gone from 0 to +2. And then similarly, to show reduction, you just go here and you write reduced underneath it. Now you don't need to put in this part if you can see it in your head. Your examiner doesn't need to see that part, but maybe for now it will help you work out what is what. And the other thing we're going to do, I'm going to do this in red, is the other part of the question that it asks you is identify the oxidizing agent and the reducing agent. So the thing that is oxidized is reduced, so all you need to do on your script is circle that part and you say reduced, and you circle this part, or sorry, this is your reducing agent, and you circle this part here and you say oxidizing agent because it is the thing that is reduced. And the SEC, can't talk and write at the same time, the SEC is happy for you to, so the two green lines and these two down here would be your marking points for your examiner. So you don't need to confirm things. And just to be clear, if this reaction was flipped and it was the CaO, so this is why doing it the way I've just shown you is better. So if it was going the other way, it would be going from Ca2 plus to this way. So this would be a decrease in oxidation number. It would be reduction. It's easier to put this whole thing as your oxidizing agent, or just circle this part, the calcium, as your oxidizing agent. Okay, so it would just be this portion of it that is the oxidizing agent, because it's the calcium that is gaining electrons. But we'll come back to this part again at a later stage. So it is 11:08. You are free to stay and have a look at the questions. So I think in the class notebook I've told you where in the textbook you might find some of the answers for 14.1 if they're not initially obvious. And as I say, question 14.2 is for you now to figure out. If you have any issues, obviously get in touch, and if you'd be so kind as to post your photos in your class notebook. We see each other on Friday morning for a double at 8:40. Lucky us. Mr. Thompson has said, so because of, I'm going to live teach you guys all the time, if that's okay, because it's just easier for you. Next Friday, he has said that if we teach 40-minute lessons, we're allowed to take time off, because it's obviously really, really hard sitting at a computer for however many hours a day. So if it's okay with you, I was thinking that we would make our lesson off the Friday of week 1. So that is the second last period, so that we wouldn't teach that one, but we teach everything else. Does that seem okay? You can nod heads because I can see some of you. Yeah?
Yeah, that's okay.
Yeah. Okay, so the homework is on the class notebook assignment. So you need to put the photo into the class notebook. Okay, so think about it now. Currently I have hundreds of pieces coming in. For me to actually have to go out, copy all your images and put them in the class notebook is just time that I would really rather spend on something else. So if you don't think you can put the photos in, I will send you a link and show you how to do it. So you are free to go, you are free to stay. I will be here for the next 10 minutes. Okay?
Thanks.
Yeah.
Did you create an assignment?
I